Hello friends, today I will discuss on current density. Okay, current density in semiconductor as well as in conductors. In previous three class, I have already discussed on energy band formation, energy structure in semiconductor, conductor and insulator, and mobility of semiconductor and relative quotient. Today, I will discuss on current density of semiconductor as well as in conductor. This lecture is suitable for science and engineering students and it is very helpful for preparation of NET, GATE and IES exam because here I will discuss all the theoretical board question and small question and the mathematical problem related to each topic. So let's start the current density of semiconductor. Here I will discuss first the current density of semiconductor, then I will solve this problem. 1, 2, 3, 4, 5 problem. So later I will solve this 5 problem. Okay. First of all, you have to know the current density and relative parameter of semiconductor as well as in conductor. Here I will discuss type number 1 is conductor and number 2 is semiconductor. Suppose this is a conductor. This is a conductor. Okay, this is a conductor. The conductor has cross-sectional area A. So A will be the cross-sectional area. Cross-sectional area. And through this conductor there are some free electrons. Okay, this is a free electrons. So that is the n. Suppose n is the number of electrons per unit volume. Okay, and if I apply a electric field through this length, so if I connect a battery V, due to this battery, electric field will be generated through this length. Then each electron will move along this direction. Electron will be moved along this direction. Okay, along this direction. So this velocity is called the drift velocity. Drift velocity. Okay. So suppose this is a portion P and this is a portion Q. Okay, this is P portion and this is Q portion. This length suppose VD. This length is suppose VD. So VD is given by meter per second. Suppose. Okay. So in this portion PQ, this is a portion. This is a portion. In this portion PQ portion, so you have to the volume of the PQ portion will be the area, cross-sectional area and the length. This is the volume in this portion of PQ portion. The charge, number of charge, total number of charge in the PQ portion will be AVD into N, because N is the total number of electrons per unit volume. So in one volume the number of electrons is N, and the A into Vd volume, the total number of electron is N into A into Vd. Okay, so each number of charge carries charge E. Suppose E is the charge of the electron, charge of electrons. Okay, that means total charge contained in PQ portion. That means total charge will be N into E into A into Vd, because the total number of charge this. If I multiply this by E, then it will be total charge. Okay, so this is the velocity, drift velocity, and drift velocity is given by meter per second. So this total charge Q is passed through this cross-sectional area in 1 second. In 1 second. So the current I will be Q by T. Here T is 1 second, because this drift velocity is given by meter per second. So it will be NEA into Vd. So this is the current. Then current density will be current density J will be I by A. Then it will be NE into Vd. So here is this is the drift velocity. This is the drift velocity. For drift velocity, Vd equals to mu into T. This is the relation of drift velocity and electric field. So then the current density will be N into E into mu into E. Okay. Here this is this N into E. N into E, total number of charge. This is the charge density per meter cube. This is a, suppose this is P, this is rho. Suppose this is rho. Rho is charge density. Then J will be rho into Vd, or rho into mu into E. Okay, this is the one equation in terms of electric field and mobility. This is a mobility. Okay, this is a mobility, electromobility, and in terms of charge density, it will be this or this. Okay, in terms of charge density. So it is the formula charge density for conductor. Then if I think on a semiconductor, suppose this is a semiconductor. Here the charge carrier is two types. One is electrons, and another is holes. Okay, another is holes. So there are two types of carrier in semiconductor. So total charge density will be given by charge density for electron plus charge density for hole. If I take N is the number of electrons, and P is the number of holes, holes, then it will be N into E into Vd for electrons plus P into E into Vd for holes, then it will be in terms of electric field, it will be J will be N into E mu of N of electric field plus P into E mu of holes into electric field. So it will be N into E mu N plus this will be, the common terms will be E and small e. So it will be E into N into mu N plus P into mu H into E. This is the current density. Okay. This term, current density, this term, from this equation you can write that J equals to sigma into E. What is the sigma? Is the conductivity. Sigma is the conductivity. Okay, sigma is the conductivity. This is the conductivity. So conductivity is given by N into E into mu. This is the conductivity. N into E into mu. Mu is the mobility of electrons. This is the conductivity. Then resistivity will be 1 by sigma. Okay, this is the resistivity. The reciprocal of conductivity is said to be a resistivity. Then resistivity will be 1 by N into E into mu. This is the resistivity of conductor, and this is the conductivity of conductor. And here the conductivity of semiconductor is given by E into N into mu N plus P into mu H. This is the conductivity. Then resistivity will be 1 by sigma. Then it will be 1 by E into N into mu N plus P into mu N, mu P. Okay, this will be mu H. That means the mobility for holes. This is the resistivity. Now, for the applied electric field, here you have already applied electric field across this conductor. Then the electron will collide to each other. For this, the power will be dissipated. So dissipated power will be dissipated power density. You call density, power density will be J into E. So it will be J equal to sigma into E, and this is the E, so sigma into square. Okay, this is the power dissipated in conductor. Okay, this is the theoretical part in this section. Now I will discuss this problem. Okay, here you see that there is a problem. A free electron's density in a conductor is 1 by 1.1. That means free electron density here will be given by N. N equals to 1 by 1.6 into 10 to the power 22 semi-inverse cube. And electron mobility, that means mu N. Mu N is given by 10 semi square per volt second. What will be the resistivity? Here I have already deduct a formula for resistivity for conductor. This is the formula for resistivity of conductor. So I will apply this formula here. So resistivity rho will be given by E into N into mu. This is the formula. Here the one, here the E equals to the number of charge of electron. So it will be 1.6 into 10 to the power minus 19 coulomb. Here the N is 1.6 into 10 to the power 22, and the mobility is given by 10. Mu will be given by 10 semi square. So this will be cancel out, this will be cancel out. So it will be, this is a 10, so in this will be 10 to the power plus, and this will be 10 to the power 23. It will be 23, this is 1, so it will be 23. So it will be 10 to the power minus, it will be 23, and here will be 19, so 4. So 10 to the power minus 4. So resistivity will be 10 to the power minus 4. Okay. The resistivity will be 10 to the power minus 4 ohm semi. Okay. This will be ohm semi. So this is the question number 1. Now question number 2. Consider the following statement. The temperature dependent resistivity of n-type silicon is based upon carrier concentration and carrier mobility variation with temperature. Okay, so I have already know the resistivity of conductor or metal. This resistivity of silicon increase with temperature. This is not true. This is not true, because if you increase the temperature, then resistivity will decrease. If you increase the temperature, then resistivity will be decrease, because the number of charge carrier will be increased. That's why this is not true. The resistivity of silicon increase the temperature. This is not true. In semiconductor, if you increase the temperature, then resistivity will be decreased. Number 2, mobility of decreases with temperature. In previous class, I have already discussed mobility depend on electric field and temperature, and this is related by 1 by T to the power m, and m for silicon and germanium is different, so 1.3 or 2.3. So if you increase the temperature, then the mobility will be decreases. Okay, so this is true. Number 3, the carrier concentration increase with temperature. Okay, if you increase the temperature, the covalent bond of the silicon will be broken, then the concentration of carrier will be increased. So it will be, must be true. Number 3, the resistivity of silicon decrease with temperature. Okay, this is true, because if you increase the temperature, the resistivity will be decreased. So here it is 2, 3 and 4 is okay. This will be right. Okay, this will be right. Okay. Next problem. Here the conductivity of semiconductor crystal due to current carrier is not proportional to the conductivity of semiconductor. Is the conductivity of semiconductor is given by E into N into mu N plus P into mu H into, this is the conductivity. Okay, so conductivity of semiconductor crystal due to any current carrier is not proportional to the mobility of carrier. Here is the mobility of the carrier, it's present, so it is not. Here is a not. Okay, so here is not. This is depend on mobility, is depend on conductivity. effective density states in the conductivity band. Effective density state, this is the effective density state, N and P. And number 3 is electronic charge. There is electronic charge. So surface state in semiconductor. For this will be the correct D option. The surface states in the semiconductor, this is not related to conductivity in semiconductor. Okay, so this D option will be correct. Okay, the D option will be correct. Here there is another question. Here you see that consider the following statement: electrical conductivity metal. So conductivity of metal is given by N into E into mu. This is the electrical conductivity in metal. So metal has negative temperature coefficient. Negative temperature coefficient means the resistance will be increases with temperature increases. This is the negative temperature coefficients mean. The electron concentration increase with temperature. This is not true. For metal, suppose this is metal. Okay. For metal or conductor, if you increase temperature, then the number of electrons or does not increases. Okay, does not increases. The free electron will be same. So this is not true. Okay, the electron concentration increases with temperature. This is true for semiconductor. This is not true for metal or conductor. Okay, so electron mobility decrease with temperature. Okay, because mobility is depend on 1 by t to the power n. Okay, so inversely proportional. That's why the electron mobility decreases with temperature. This is true. Number 3, electron lattice scattering is increased with temperature. Lattice scattering means if there is a crystal structure. This is the crystal structure. Crystal structure. This is the lattice point. Lattice point. If you increase the temperature, then this lattice point will be vibrated. Each point is vibrated. If this vibrated, the scattering will increase with temperature. So if you increase the temperature, then vibration will be more than the scattering in increase. Lattice scattering will be increases with temperature. So this will be true. For this question, only 2 and 3 is correct. Okay, this option will be correct. So this option will be correct. Okay, so there is another question is 21. This question is a pure silicon. There is a pure silicon. Okay, for this pure silicon, resistivity of pure silicon is that means rho is given by 3000 ohm meter. Okay, pure silicon. Carrier density, free carrier density is given by this. That means Ni is given by 1.1 into 10 to the power 6. The mobility, the electron mobility, that means mu n is 3 times the whole mobilities. That means 3 of mu h. This is given. Calculate the value of electrons and holes. Value of electrons and holes. You have to calculate value of electrons and holes. Okay. So for this portion, here you see that for this portion, here I will discuss. So the conductivity sigma is given by sigma is given by n into p into mu n. Here is b n and plus p into mu h. P and n will be ni, then it will be ni into mu n plus mu h into e. For ni equals to n equals to p. This is called This is for intrinsic semiconductor. Okay, this is the intrinsic semiconductor. N equals to P, and this will be given by Ni. For intrinsic semiconductor, the conductivity will be given by this. So here here the this is the formula. Okay, then here the resistivity. So resistivity rho is given divided by Ni into mu n plus mu h into E. If you apply this equation and this equation, then you will be able to calculate the number of electrons and number of electrons and holes. Okay, so for this, here this is the equation, such that means resistivity rho equals to 1 by Ni into E mu n plus mu p. This is the equation. Here the resistivity is 3000 equals to 1 by Ni is given by 1.1 into 10 to the power 6 into E is given by 1.6 into 10 to the power minus 19 coulomb. Here is mu n is given by 3 by mu p. This is the condition number 3. Here you see that this is the condition. The mobility, electron mobility is 3 times the hole mobility. So mu of n equals to mu of p. So it will be given by mu is equals to 3 mu p plus mu p. Okay, so it will be 3000 1 by 1.1 into 1.6, and this will be minus 13. Okay, and it will be 4 mu p. So mu p will be 1 by 1.1 into 1.6 into 10 to the power minus 13 into 4 into 3000. This is the mu p. That means whole mobility. Okay, this will be the whole mobility. So if you calculate this, this will be the value will be given by 4.7348 into 10 to the power 8 meters square into 4 second. Okay, this will be the number of mu p. Okay, then mu n will be 3 times of mu p. So it will be 3 into 4.7348 into 10 to the power 8 meters square whole second. This is the answer. Okay, so here I have discussed all the problem and theoretical concept. So the next class I will discuss on the action law, mass action law. Okay, so